Hello everyone. Here in this lecture we are going to discuss about the Lagrange's mean value theorem, its proof and its geometrical meaning. First, the statement of the theorem. Okay. If a function f is continuous in closed interval AB and differentiable in open interval AB, then there exists at least one number c belongs to open interval AB such that f of b minus f of a divided by b minus a is equal to f dash c. So this is the statement of the theorem, and previously we have discussed about the Rolle's theorem, and the Rolle's theorem was that if a function f is number one continuous in closed interval AB, differentiable in open interval AB, and the value of the function at endpoints is same, then there exists at least one c belongs to a b such that f dash c is equal to 0. The Rolle's theorem is the restricted version of this mean value theorem, and it is more general. Why? Because there is third condition in Rolle's theorem that f of a is equal to f of b, but there is not any third condition. And here we are saying that in the Lagrange's mean value theorem, if a function fx is continuous in closed interval AB, differentiable in open interval AB, then there exists at least one c belongs to AB such that this quotient f of b minus f of a divided by b minus a is the derivative of the function at that point c. Okay. Let's first discuss its geometrical meaning. We are saying that this function, let us suppose that this is the graph of the function, and this function is continuous in this closed interval AB, and this function is differentiable at every point of this open interval AB. Then if we join these endpoints of this curve, okay. Now, what is the slope of this line? The slope of this line is equal to f of v minus, because this point is a f of a and this point is b f of b. And what is the slope of this line? So the slope of this line is f of v minus f of a divided by b minus a. This is the slope of line. So left hand side of this equation is simply the slope of this line. Now what we are saying here, that there exists at least one c belongs to this interval where the tangent line to this curve is parallel to the line joining these endpoints. क्या कह रहे हैं हम? ये कह रहे हैं कि इस ओपन इंटरवल में कोई पॉइंट हमें C ऐसा मिलेगा such that इस पॉइंट C पे, if we draw this at this point C, the tangent line, that tangent line will be the parallel to the line joining these endpoints. यही इसका ज्योमेट्रिकल मीनिंग है, ये मैंने लिखा भी है. There exists at least one point in open interval AB. This open interval AB, there exists at least one point in this open interval AB for which tangent line is, here is the tangent line, for which the tangent line is parallel to the line joining endpoints of the curve. These are the endpoints of the curve, and this is the line joining, and the slope of this line is this, and therefore the slope of these two lines, tangent line and this line, is same. So यही इसका ज्योमेट्रिकल मीनिंग है कि अगर कोई फंक्शन कंटिन्यूस है क्लोज इंटरवल AB में, डिफरेंशिएबल है ओपन इंटरवल AB में, तो एक पॉइंट C पक्का मिलेगा. यहाँ पे अगर हम टेंजेंट लाइन ड्रा करें, दैट टेंजेंट लाइन विल बी पैरेलल टू द लाइन जॉइनिंग द एंड पॉइंट्स ऑफ द कर्व. अब इसका प्रूफ कर लेते हैं. जो इसका प्रूफ करेंगे वो हम रोल्स थ्योरम को यूज करके करेंगे. तो सबसे पहले वी विल डिफाइन अ फंक्शन. Define a function. Let's suppose this function let's give the name to this function is phi of x. Represent this function by phi of x is equal to f of x minus f of b minus f of a divided by b minus a multiply by x. Right now, f of x is continuous in closed interval AB and differentiable in open interval AB by because this is a statement of the theorem that f is continuous in closed interval AB and differentiable in open interval AB. So fx is continuous and the second part of this function is simply the constant multiple of this function x, and x is, we know that it is the identity function and it is continuous and differentiable everywhere, right? Therefore phi of x is continuous in closed interval AB and phi of x is differentiable in open interval AB. And the third condition of the Rolle's theorem, phi of a. Let's find phi of a. Let's find value of the phi at end point of the interval. Endpoints of the interval. First, let's find phi of a. Phi of a is equal to f of a minus f of b minus f of a divided by b minus a multiply by a. Okay, so if we solve this equation, we will get b f of a minus a f of a minus a f of b plus a f of a divided by b minus a. This is a f of a, this is a f of a, ये हमारे कैंसिल हो जाएंगे. नाउ phi of b निकाल लेते हैं. phi of b is equal to f of b minus f of b minus f of a divided by b minus a and b, which is equal to b f of b minus a f of b minus b f of b plus a plus b f of a divided by again b minus a. So b f of a, b f of b, this is b f of b. So therefore this implies phi of a. If we see these two equations, we will find that phi of a is equal to phi of b. Now we have three conditions on phi. Phi is continuous in closed interval AB, phi is differentiable in open interval AB, and third condition is the value of the function is same at the end point of the interval. So therefore phi satisfies all conditions of Rolle's theorem. Hence there exists one number C belongs to open interval AB such that phi prime C means the derivative phi at C is equal to 0. This implies, now derivative phi is derivative f at C minus f of b minus f of a divided by b minus a, and the derivative of x is simply 1. This is equal to 0. This implies f dash c is equal to f of b minus f of a divided by b minus a. So this is the proof of the Lagrange's mean value theorem, right? So अभी के लिए इतना ही. Thank you.